Hello everyone, welcome to Computer Science E76. This is lecture 6, the final chapter on Android, and we're going to talk today about storage and threads. Now, last week we started talking a little bit about some storage stuff, and specifically we started talking about preferences. And really there's a variety of ways that we can store data on an Android device, only one of which of those is that preferences. And so we saw in the example that we had a chance to talk a little bit about, there was the get preferences method, which allows us to actually fetch preferences within a specific activity, but then there's also a get shared preferences method that allows us to use the same preferences across a host of activities within our same application, or within the same application that we have created. And so last week, one of the final examples that we were trying to go over was in fact that storage O2 example. And there were just a couple of things that I wanted to point out in case they weren't terribly clear from last week, since we did have to go over it somewhat quickly, and that is these things. So first of all, of course, we've talked at length about how we have to save state for our activity because of this activity life cycle. How, of course, activities are created and started and resumed, and then once they move to the background, they're either paused or stopped or so on and so forth, depending on what happens to them in their life cycle or what other activities have come to the foreground. And we've talked at length about how it's a really good idea to save state on the on-pause method, because after that point, it really is possible for the Android OS, although unlikely, to actually kill your activity, and therefore you lose all of the state associated with it. And how we've talked about then, perhaps as a consequence of that, one of the nice ways or the good methods to implement loading that state is in the on-resume method. And this is, of course, something that makes a lot of sense, I hope, to all of you that have been working with preferences and have looked at the activity lifecycle, but realize that these are not, of course, hard and fast rules. You can implement saving and restoring of state in any one of the activity lifecycle methods as you actually find appropriate for your application. And I'm not saying necessarily that there's better options, but that perhaps what works for one application is not always going to work for another one. So just keep in mind that just because we talked at length about why it's a good idea to restore state in on-resume, it's not necessarily the case that you have to. There might be reasons why you would not want to restore state in on-resume, and perhaps you would do it from an earlier method in the activity life cycle. But in the example of code of storage O2, rather, we do in fact use that exact thing that we talked about, where we save state in on-pause and we actually want to restore state, or rather specifically what one activity is doing, the main activity is doing, is restoring state in the on-resume method. And so if you didn't get a chance to take a look at this source code, I do actually just want to run it very briefly so that we can show you how it works. So we have coming up in the emulator here this activity. And this activity basically is just a text view that displays some text, and that text happens to have some very simple styling. And if we go to the settings, which is just a separate activity, we can actually modify that text that was displayed in that first activity. And we can share this data between the two activities. There's a variety of ways we can share data, but we can share this data between the two activities by using shared preferences, so stating in this second activity what we actually want that first activity to say and also stylize it. But the reason that we're not using other means of passing data to and from the first and second activity by way of intents perhaps and returning start activity for results method and other things like that, is that we actually want this to persist whenever the app is closed down. So this makes perfect sense then for us to do it. So as you can see, I saved the changes that I made, and it resumed the previous activity, and the changes were then updated in that previous activity. And so for this example, it actually makes a lot of sense for us to use on resume, because whenever we've loaded up the settings activity and modify the text within it, or modify the style within it, and we save it, we want that previous activity, as soon as it's being resumed, to pick up whatever changes we had made and saved in this second activity. So for this reason, in this application, it makes a lot of sense for us to use the on-resume thing, just like what we have talked about in a variety of times before in relation to the activity lifecycle. But if it just so happens that you don't have other activities that are impacting that same data, then you might decide that it's actually important, or you might decide that it's useful to implement loading that data from a previous method in the activity lifecycle. You just said this is something. There's no real rule that I can tell you that says, oh, if you're doing this, then you should do it in this method. If you're doing this, you should do it in this method. It just takes some thought on your part based on the activity life cycle and based on what you know your activity is trying to accomplish to determine which of those is going to be appropriate for loading and saving data. Now, a couple of other things that I want to point out. As opposed to storage 01, what we're using here is this method, the get shared preferences method. And it's important to note that the get preferences method basically just piggybacks off this method right here, get shared preferences. But whereas in this method, we can provide a string, in this case, pref's name, which is just the constant that we've defined at the top of the activity, in fact, at the top of both activities, so that we can reference that same set of preferences in both. It just so happens that get preferences uses the activity name as this, as the name of this get shared preferences. So you can actually find that same file within your within the hierarchy in your file system of your Android device, or more specifically your emulated device. So in this, it works very much the same as the other preferences methods that we saw before. If you actually want to edit them, then you can, in the case of settings up here, you create an editor. And from there, let's see, so here you create an editor, and then you can provide a number of settings in key value pairs, and then also commit that to the file system, and then that will be loaded in the previous activity. Now, there's one more thing that I want to show you with regard to this, and that is that all of this stuff that's created is actually stored in a way that's not all that difficult for us to take a look at and understand. Now, one of the things that's important to realize is that in order for us to be able to do this, we have to, in fact, be running an emulator. And in fact, one of the benefits now, we've talked at length about why using an actual device as opposed to an emulator has a number of advantages, but in the case of the emulator, the file system is not as rigidly locked down, and we can in fact take a look at some of the contents that our activity, or rather our application, has stored. So if we take a look here, the hierarchy is such that if you go to /data, the package name of your application, you can actually find some of the data that's been stored by that application. And in this case, we can see that we have a shared preferences directory right here. If we take a look, we can actually see what that shared preferences file is just saved as an XML file. Now, I actually haven't found any text editors on here for us to be able to edit this text, but I believe we should be able to at least see what this looks like. Yeah, there we go. So we can actually, it does have, in fact, in this limited shell, it does have the cat command, which allows us to output the contents of this file, and we can see that we have saved what this file actually looks like. And in fact, this is also important to realize that your shared preferences file is just an XML file that's not encrypted or anything like that, and it is possible for a person to be able to manipulate it. It's not necessarily easy, especially on a physical device where the permissions are set such that a standard user would not be able to look into the contents of this directory, but it is still possible, and that's worth paying attention to as you are writing applications outside of the context of this course. Any questions on this before we move on? All right. So I mentioned that there's a couple of other ways that we can store some data. One of the things that we haven't really had a chance to talk too much about are files. And in fact, that's not something that we're going to get a chance to talk about too much. But if you do want to read and write raw files, then take a look at these classes and methods. So using the context class .openFileInput and openFileOutput, can you actually stream data to and from the device itself? And that's if you really have, if you are generating raw bits or raw bytes that you actually want to store or read from the device, that's going to be useful, but not necessarily something that we'll talk about now. I think I saw a question a second ago.
Yes, on the shared preferences, is there a limit on the amount of data? Is there a point where you say it's not good to use that?
Is there a limit on the amount of data where it's no longer good to use shared preferences? So shared preferences is supposed to be lightweight. It's supposed to save state for the activity. So you really shouldn't be using it perhaps as a database to store large amounts of data that you are generating in the application or anything like that. It really is just meant to save the state of the activity itself so that when you reopen it, it can be loaded and resume in the same state that the user had left it in. So if you actually need to use something else entirely, like you need to be able to create large amounts of GPS data, for example, or you need to be able to store contact information or any number of things like that where you have more than just a few things that you really need to store, then that's when you should move away from using shared preferences. In fact, use the last example perhaps, but as databases, where you can actually use a SQLite database to create and store a variety of data within some SQLite databases and reference them relatively quickly. And the context then is a little bit different, because no longer is this meant to be state for the activity itself, but perhaps some data that you're actually trying to save for your application as a whole. As far as a hard limit, I couldn't say, oh, if you have more than 50 variables, then that's maybe too much. It really depends on your own application and the goals of that application for you to decide what is the upper limit on your own.
But like 100 KB, 200 KB, that would be okay, right?
100 KB, 200 KB, it might be. That sounds like quite a lot of data to store, because the Android devices are, in fact, a lot of mobile devices are I/O limited, and so writing that much data could actually take a non-trivial amount of time, or it could take long enough that the user might perceive the few hundred milliseconds that this might take. I'm not actually sure if that's how long it could take, but you really want shared preferences to be as lightweight as possible, because usually you're writing and restoring this data in the activity lifecycle methods, which really need to be fast so that the activity can load or close or what have you, so that the user can move on to the next thing. So really, it's really important to stress that it's meant to be lightweight, so you really don't want to store that much data within it. If you really have that much data, that's probably where I would start considering using something else like a database to store that much data, because that sounds like quite a bit of data to store. All right, so in the context of SQLite, realize that SQLite is actually it's essentially just an application that you can run. How many of you are familiar with MySQL or have used MySQL in the context of web programming? Okay, so a lot of you. So you will then feel comfortable, perhaps in a way, with SQLite, because there's a lot of similarities between MySQL and SQLite. Most notably, the query language that's used is in fact the same. But there are in fact some important differences that are worth noting between MySQL and SQLite. Now, one of the first things that I want to point out is that SQLite 3 is just an application that you can run within the shell of your Android device. And again, this is something that's limited to the emulated devices. We wouldn't be able to use this same command when accessing the ADB shell of an actual physical device unless we've rooted that device, because the permissions don't allow us to do that. So again, this is one of the ways that the emulator is sort of an enhancement, perhaps, in some ways, especially when testing over the physical device. But using this, can you actually connect to a database file and use and issue SQL commands to that file? Now, basically, what SQLite 3 is just a program. It's just an application to which you issue commands that don't look like other Java commands or anything like that. There's this very specific query language associated with it called SQL that allow you to perform manipulations on the data stored within that database. Now, SQLite 3 stores all of the data in a database in one file. And this is unlike if you're familiar with MySQL, where MySQL will actually create multiple files, perhaps for each individual table within the database. SQLite 3 will actually create one file for every database that you create, and all of the tables that are associated with that database are stored within that same file. So this makes it pretty easy for us to be able to point SQLite at a specific database and issue commands to it. And you might have heard that I'm using some of these terms like database versus a table. A database can just be a collection of tables. If you've ever used Microsoft Excel, you're basically using a relational database, which is very similar to SQLite 3 in the context of how the data might be organized, how we could consider that the data is actually organized. In Excel, you might have a single Excel file that can have a variety of sheets, and each one of those sheets is basically just a separate set of rows and columns, and you can input data, different data in each of those sheets. And it's a very similar concept in SQLite 3, where you have a single database, which is like that Excel file. You have within it different tables, which is like that separate sheets, where you can store different amounts of data in each table. And there's whole courses devoted to creating and optimizing efficient databases and all of this sort of stuff. And we really don't have the time, as you can imagine, to be able to talk about the intricacies of using SQLite. But there are a couple of important things that are worth noting. And that is, first, this sort of thing, but also that SQLite 3 can be used as a very lightweight way of storing and retrieving data within a database. So this is going to be a command that will be relatively useful for those of you that need to use SQLite 3 for your student's choice applications. And this might be your best friend then, so you can actually take a look inside of the database that was created on the device and modify it perhaps, or even be able to take a look at some of the data that's held within and be able to manipulate your application in that manner. Now, I mentioned before that in order for us to manipulate the data or to fetch the data within SQLite 3, we have to use that command or that query language called SQL. So realize that there's really a variety of major SQL commands that you will probably use, and these are some of the major ones. There's perhaps others, but tables, for example, we can modify tables with the create table statement, or we could alter that table, or we could drop that table, which basically means just to delete it. Dropping is kind of a dangerous operation, so take care when you use that. Or when you want to modify individual rows within the context of a single table, can you select it or insert or update or delete? And there's more advanced things that you can do, like joins and be able to fetch data from multiple tables and that sort of thing. But really for this, for what we need to do here, we'll just take a look at some of these simpler examples with a single table. So what does then a sample SQL query look like? Well, here's an example of how perhaps we might actually want to update a single row within a table that's housed within a SQL database. And so this might look very familiar to those of you that have used MySQL, and in fact it's the same language and it works very much the same, but really underneath the hood there's some differences between SQLite 3 and MySQL about what's actually happening here. But really, if we take a look at this, it sort of reads like a sentence, right? Update users. Users in this case is just the table that's housed within our database. We want to set a field called email equal to some value, in this case the email address of help@cs76.net. We also want to specify a user ID. So perhaps the analogy between Excel and SQLite is sort of a loose one, but really the analogy breaks down very quickly when you realize that you can modify the Excel table in a variety of ways, not only in the columns but also the rows. But in SQL, typically what you do is you predefine the columns, or what are known as the fields, for that table. So you might have, for example, an ID number field. If you have, let's say you have a table of users, some of the fields that you might actually have would be an ID number, and also a username, and also an email address, and perhaps a password, and perhaps some other things that are related to that user as well, maybe first and last name or what have you. And then as you add data to it, you just add rows and fill in each of those fields associated with those columns. And so really that's basically how this is functioning. And what we are doing with this SQL statement right here is we are identifying which row it is that we want to modify in the clause that says where user ID equals 4. And we're changing a specific column within that row with the set clause. So set email equal to that, where that user ID happens to equal 4. So hopefully that's relatively straightforward. Notice a couple of things. First of all, this clause in fact ends in a semicolon. So if you're going to issue commands to the SQLite database, you do in fact need to end your statements with a semicolon, otherwise it will not work for you. So really, SQL is just a standard query language. This applies to MySQL and a variety of other SQL languages as well. And really, if you know that stuff, you can bring that knowledge into SQLite 3 and use that pretty reliably. Now, there are some differences. We're not going to get a chance to go over all of them, but if you're curious, take a look at the documentation that's available from SQLite.org that goes into a lot of detail about what's different with regard to the types, with regard to how data is stored and how it might be a little bit different than what you're expecting from other SQL query languages. But really, the vast majority, the bulk of what we need to talk about really comes down to, and when we're talking about comparing MySQL, for example, against SQLite 3, is how SQLite uses data. So SQLite actually uses very loosely typed data, which is very much in contrast to MySQL, where you rigidly define for every field, for every column in your table, you rigidly define what sort of data can go into that column and the length of that data that can go into that column. Well, really, you can still apply similar constraints in SQLite, but really that underneath the hood, that's not what's really happening. All of this data is sort of stored in variable lengths in SQL, and basically all of the data types that are associated in SQLite 3 are basically suggestions rather than hard and fast rules. So this is kind of an important thing to realize. While many of the queries will work, importing them from, say, MySQL and using them within the context of SQLite, just realize that underneath the hood, there are, in fact, some differences. So these are the major storage classes that are associated with SQLite. And if you're familiar with MySQL, again, and some of the data types therein, there are a whole bunch of data types that are associated with MySQL that are just no longer present in SQLite 3 due to this oversimplification, not oversimplification necessarily, but simplification in the data type so that SQLite 3 can be small and efficient and run quickly on a device like like an Android device. So here you can see we have these different storage classes: the null value, integers, real, text, and blob. And so this is pretty much it. The integer is stored in variable byte lengths depending on the value that you provide to it. Let's see, there's some other information here. You'll notice that there's no Boolean, for example. That's just stored as a 0 or a 1 in an integer field, so on and so forth. Now, when we're actually defining columns, we don't really define, again, rigidly the type of data that's stored within this column or within a field in SQLite. But rather, as we define a table, as we create a table in SQLite 3, do we give that column an affinity for a particular type of data? So again, this is loosely typed. We can't actually tell SQLite how we want to store this data or how we want it to store this data, but we can tell it that we do imagine that for the vast majority of data that we're inputting into a specific column, it's going to match one of these types of data. It might be text, it might be numeric, it might be integer, it might be real, or it might have no particular affinity, so that SQLite can pick however it wants to store that particular data. Now, this isn't meant to be confusing. Really, this just means that it's loosely typed. If you just input a bunch of MySQL statements into SQLite 3, it for the most part will work exactly as you expect. It will create a table. If you create a table with some strict types, it will create a table, but it actually has some rules that it will follow to determine which affinity each column will have based on how you've defined each field in your SQL statement. When you perform selects, it will try to retrieve that data in the affinity of that particular column, a variety of other things, but just realize that I'm just trying to point out that there are, in fact, these differences between the two. Now, if we were taking a look at column affinities, how it actually breaks down a typical create table statement into these various types of type affinities, just follows a variety of rules that look like this. And again, all of this stuff is found in the documentation. I highly recommend that you take a look at it. Basically, if the type contains for a particular field contains int, which might be big int or integer or what have you, then it's just going to assign it an integer affinity, so on and so forth, for a variety of the data types that you might expect in a typical SQL query language. So what all of this means is that SQLite 3 is just a much simpler version underneath the hood than compared to some of these other query languages that we've seen, or some of these other SQL query languages that you might have worked with, including MySQL, Postgres, so on and so forth, MS SQL. So how then can we actually implement this within an application? What if we actually wanted to create an app that uses SQLite and allows us to store a variety of data within it? And that's exactly the point of Code 3. So what does Code 3 do? Well, realize that this is a rather contrived example, but there's a very good reason that I'm doing this. If we take a look at what it looks like, as soon as it compiles and loads, you'll see that here we have two fields in our activity, username and a password field. And we have two buttons. One of them is to authenticate. So essentially, we might consider, oh, maybe this activity is really meant to show how we could use SQLite 3 to store a database of users, so on and so forth. Not really, and you'll see why in just a moment. But also next to that, you'll notice that there's a save login button. And so really, this is kind of where it breaks down. Obviously, it's not going to be too great of an authentication mechanism if I can just create a sign-on, save it within our database, and then use that to authenticate. But really, this then shows us how we can interact with SQL and what some of the results are for using some of this sort of idea using a SQLite 3 database. So just based on me having compiled this application and having run it within this emulated device, has the database in SQLite 3 actually been created? So if I actually want to manipulate it, then I just have to manipulate that file that's been created. So you might recall that one slide where I said you go to /data/data/ your package name /databases/ the name of the database. And that's exactly what I've typed here. I'll really copy-pasted it because it's kind of lengthy in this example. And if I hit enter, you'll notice that it enters SQLite 3. And so now I can pass those, I can now create those statements that I mentioned before. I can actually issue these statements in this ADB shell. And rather what this is this is SQLite 3, the program running within the ADB shell. And I can perform queries against this database to look at the data, to see if there's any data in there, to see what sort of tables actually exist, so on and so forth. One of the most helpful things that you will find is .help. That will actually give you a list of some of the non-SQL statement commands that you can issue, like if you want to quit, for example, or if you want to see a list of tables, variety of other things. That's all listed within the .help command. But if I want to see a list of tables that this database, and again, remember that a single file houses, in fact, a collection of tables, I can actually find out which ones there are by running this .tables command. So .tables shows me that there are two tables created within this database. One of them is Android metadata, as you can see there. The other one is users. And so users is a table that I've actually created, and Android metadata is one that the Android OS has created. And we can actually see what these actually look like. So what if I wanted to see all of the users that exist within my users table? Well, I can run a very typical SQL command, select star from users. Oops. I can hit enter. You notice that it returns nothing. That's because there is, in fact, no data yet within this table. So perhaps one of the things I could do is go back to my application and inject a couple of rows into it by typing in a username and password. But what I want to do first is actually insert some stuff using a typical command, using a typical SQL statement command. And the way that I can do that is with the insert into command, insert into users. And I want to tell it which fields I want to modify. So in this case, I have two fields, user and pass. And I have two values. So I'll do, say, Dan, and then my password will be 1, 2, 3, 4. When I hit enter, it doesn't return anything, but I can now see what fields I have or what data I have within my table by running that select command again. We can see that it looks like there's three things that have been passed back. And those three things are, in fact, just columns within my single row. So I have here, you can see Dan and 1, 2, 3, 4, which are the two sets of data that I inserted before. But what do you think that 1 is? If you're familiar with MySQL, what might we have implemented here with this very first column, this very first field? Yeah, primary key. So just an auto-incrementing integer so that we can always reference a specific row very easily because it's an integer and we can reference one specific row. So let me just insert another row as well so that we have a couple of things to work with. Insert into users, user pass, values. I'll do jharvard and jharvard for the password. Not very secure, but neither was mine. And now we can see the same thing, how we now have two rows of data here. So now we're actually manipulating the database that this application is using live. So this means that I have just inserted those two rows so I can actually use them as a means to authenticate. So jharvard here, click done, click authenticate. You can see at the toast that appears at the bottom, it says jharvard has in fact authenticated. Now if I mistype the password and I click authenticate, notice that it says authentication failed for jharvard. So basically what we're doing is we're fetching the username and password from the respective fields in our activity and querying the database to see if those values exist as in a single row within our users table. But notice something else, and this is perhaps one of the reasons that using SQLite for authentication like this is a big no-no, and that is that all of this data is in fact stored in plain text. And unlike MySQL, if you're familiar with that, there's no encryption function that's automatically built in that allows you to nicely encrypt a password, for example, and store it within the database. If you want to encrypt your text, you'll have to implement an encryption scheme on your own and then save that encrypted text within your SQLite database. So this is just sort of a warning that I'm trying to show you here, that all of the data stored within SQLite is typically done in plain text, and if somebody has access to your application, they could run it in an emulated device and see what data you're actually storing and how that actually looks. So just another, in practice it may not, it really depends, I guess, on the application that you're implementing, but for most things it doesn't matter too much, but just keep that in mind if you're storing perhaps any sort of data that you might consider sensitive, whether it be the user's data or some other data that, that's relevant to your application. All right, so this is all pretty high-level stuff, but how then in code do we actually implement this? Well, notice that we have a couple of things going on here, and the first is in our in our application, we have, of course, our activity, but notice that there's one thing that's kind of interesting here, this line of code right here, where we instantiate a DB adapter. Now, DB adapter isn't implemented for you. It's something that you will need to implement, and that is found right here. So this DB adapter is really what is responsible for connecting to SQLite 3, creating a database, creating a table if it needs to do that, inserting data into the table, fetching data from the table if it needs to do that. This really is just meant to be an interface through which we can provide or we can query for data or fetch data and pass that back or use that data in some way that's useful in our original activity. And in fact, our activity is relatively easy. Notice that we connect to where we instantiate our DB adapter. We open a database connection with DB open. All of this happens in onCreate. If we take a look at when we click on things, for example, this is really done in a very easy fashion. We just insert a user into our DB because we've implemented that DB adapter. We can implement arbitrary methods that allow it to, that make it easy for us to do this, that abstract the need to actually know SQLite commands away from that adapter and just being able to run this in raw code. If you're familiar with this concept of model view controller, this is sort of one way that we can separate having our data model from the presentation of that data. And then also we have db.authenticate user. So these are methods that have been implemented to try to figure out if, or rather, these are methods that we've implemented to either insert a user into the database or find out if a user has actually been authenticated respectively. Now, if we wanted to do this in say, SQLite statements, how would we actually do this? Well, we've already seen how we can insert a user, but how might we authenticate a user in the context of a SQL statement? So let's say that a user has provided to me their username and password. How can I actually find out if that user exists within the table? Yeah?
You select from the users where the username is their username and password is their password.
Right, so we can actually select start from users where and then we enter in their username and their password. And hopefully this will work. We can find out that we get this that's returned. And so we get back then the one row that satisfies the conditions where the username is this and the password is that. We get back that one individual row. Now we can take this sort of a step further and we can say that we only really want to find out if that row exists at all. So we can really find out what the count is, how many rows we have received back from this query. If it's exactly one, then we know that that user has authenticated. If it's more than two, then there's probably something wrong with our database because we have allowed multiple instances with, we've allowed multiple rows where we have the same username and the same password. If we get less than one, then obviously one of those two doesn't apply, and so the user has then not authenticated properly. So then let's keep all of this in mind then as we go through the DB adapter, this database adapter that allows us to abstract all of this content or to abstract all of this information away from actually having to implement this within our activity. So we have here a DB adapter. We need to do a couple of things within it. First of all, we need to define what the database name is going to be. Second of all, we need to define any and all tables that we're going to use within this database. And so that might include all of the fields that are associated with each of these tables. So you've seen that we had a users table, and the users table was contained within this database called db_example, and also that table had three fields: an auto-incrementing ID field, a user field, and a password field. So really then, the first few constants contained within this adapter just define all of that information. Now, generally, when you're working with auto-incrementing fields within SQLite database in Android, it's a good idea to always use _ID because it's been optimized. It's actually used by Android and by some of the abstractions that Android provides to be able to identify specific rows. So use _ID. That's pretty much a great way to identify which are your auto-incrementing IDs. Then we have defined our other fields as well, user and password. We've also defined the name of the database and also the name of the table in addition. And you'll notice that we have here another constant based on the database version. We'll get back to this in a moment and why this is important, but this should be, you should keep track of your database version in an incrementing integer. So if ever is the case that your application grows in complexity and you need to change your database a little bit, then you will want to increment that by 1. We'll see why that's important in just a moment. Now also, we need a way of being able to create the table within this database. So we just have then a standard create table statement, as you can see here. Create table users, we pass into it the 3 fields that we've defined, ID as an integer, primary key, auto increment, the user and the password, which are both going to be text fields, and they also both cannot be null. Now you'll notice that we have embedded within here another class, and we'll get back to that in just a moment. But if we take a look then at some of the other things that we've implemented a constructor for this DB adapter where we pass in the context of the calling activity. And then we also have to implement some of these other methods as well, like, for example, the open method, which, as you saw, allowed us to open a connection to the database. Then we have, of course, some of the other methods as well, like insert user, which allows us to insert a user into that database, and the authenticate user, which allows us to query the database to find out if that user has properly authenticated. Now, all of this cannot be done, though, without actually creating a connection to the database. And the way that you do that is through this class called SQLite Open Helper. And if you extend this class, can you actually then override some of the methods and be able to easily create a database without having to write a lot of code, but can you easily create a database and also all of the tables associated with it? So really, this is the object then. This object right here, our database helper, contained within our DB adapter, is the object that's actually going to perform the raw queries against the database. It's actually going to be the thing that opens the database connection, that creates the database file, that actually creates the tables within it, performs queries if we need to, or performs queries if our DB adapter requires us to perform queries, so on and so forth. All right, so if we take a look then at some of the methods that we implement within this database helper, one of them is a constructor, which is of course going to be very useful. But what we need to do within this constructor is to pass a couple of things to the parent, to the calling class. In this case, it is the name of the database. In other words, what file should that database be written as on the actual file system itself, and also the version of our database. And again, we'll get back to this in just a second. Now, if it just so happens that this is the very first time that this application is being run on a particular device, that means that that database has not yet been created. So what what this class needs to do, the database helper needs to do, and more specifically the SQLite Open Helper class needs to do, is first to create that database and then to create the tables that we're going to use within it. And so then, if the SQLite Open Helper decides that, okay, well, for this DB name, we do not yet have that created. So what we need to do is to actually create that. We will create the database and then call this method onCreate. And what we can do then is we can then execute that SQL statement that allows us to create the tables. In this case, we only have the one table, so we only need to execute that one statement that allows us to create that single table within that database. And this is why when we first opened up this application, then we went to SQLite 3, even though that was the first time that application had been run in this emulator, we actually had that table predefined. It was because of this function right here. The SQLite Open Helper realized that the database had not yet been created. It needed to create it and also to create the tables, and this is how it performed that. Now, this database version is important because if it just so happens that you have an increase in the database version, let's say that the user has been using an older version of your application for some amount of time. Now it just so happens that you update your application, but also it's gotten a little bit more complex. So you have a few more tables perhaps, or you've changed the structure of some of those tables to better support a variety of new features in your application. Then what you're going to do is increment that database version by 1. But because you have passed that database version into the SQLite Open Helper, it realizes that then there is some update to that data, to that database, and that you need to actually perform an update against the old version of the tables and the data that's stored within your database to bring it up to spec to how it should function now. Now, if that's the case, that the database version has been upgraded since the last time you've run this application, then it calls this onUpgrade method. And in this case, what we're doing is overly simplistic, but it's effective for this one, where we're just completely destroying the old table. In this case, we're just dropping the old user table, and then we're just recreating the new one, if it happens to be recreated. Now, if we were actually implementing this in a production-level application, you should be sure to pass or to send any data over from your old tables over to the new ones and upgrade them appropriately. This could be then a little bit more complicated of a method than is shown here, but still, this is sort of a useful method that allows you to upgrade cleanly your applications without having to worry about the integrity of your data that's stored within the database, because you have full control over how that's actually updated. All right, so if you actually have then created this database helper, what happens to get returned to you then is, in fact, that object, and you can actually fetch the open database connection from that SQLite Open Database. I always forget the name. SQLite Open Helper, rather. So within the context of this open method that we've implemented within our database adapter, so keep in mind this is sort of the adapter that we've been implementing in this entire Java file, then all we need to do is instantiate a new database helper. In this case, again, the database helper is the thing that actually communicates with the raw database. It's actually performing and sending the raw queries to it. And our DB adapter is really an abstraction around that so that we have those methods like insert user and authenticate user. So those methods then communicate with this database helper, and those are the methods that actually perform those raw queries. Or that tell the database helper to perform those raw queries against that database. So here we have just an open method that allows us to instantiate a version of that database helper. And also, if we run then this getWritable database method, what it returns to us is, assuming all went well and everything has been created, our database file has been created, our tables have been created successfully, we will in fact get returned to us a database connection that is now open and that we can now use as a result. All right, so then how can we actually implement some of those raw SQL statements within the context of our other helper methods? Excuse me. We'll realize that Android provides a lot of helper functions that allow us to abstract the need to actually write raw SQL statements for a lot of things that might normally you would have to create by hand, perhaps. So notice that here, for example, in our insert user method, we have a couple of things. First of all, we're going to create a new variable called vals that is of type content values rather. And what this allows us to do is to push key value pairs. And what we can do within that is to tell, or we can specify the fields that we want to update within our specific database. And then all we have to do is run db.insert, the name of our table, and also the values that we are trying to insert. So within this db.insert method is it actually taking all of this stuff and creating that query that you saw before, insert into users, in parentheses, the name of the fields, the names of the fields that we want to update, and then values, and then the names of the values that we want to implement. Now the reason that this is useful is because this ensures that the data that's going to be passed into the database is going to be safe. Typically, if you're familiar with SQL injection attacks, and again, this is a whole host of issues that we could talk a long time about, this helps protect us from it because from that issue, because it can individually take a look at the keys and the values and make sure and sanitize them to make sure that they're actually safe before creating the query that is going to be issued to the SQLite database. So then you really don't have to, while it's useful to know those SQL statements, because then you can actually issue those statements directly to your SQLite database to sanity check the data that's being created by your application, or to insert random new rows to see how it's going to behave depending on how your application has been written. This is then that equivalent in Java code. Now, if we want to perform a query where we actually want to fetch some data from the database, we need to use this object called a cursor. And the cursor is really just a way of iterating over a variety of data sets to iterate over some data set that's been returned to us by the database. But within it, do we specify a couple of things? So really, this is like we are creating this select star statement, but doing it in just raw, or doing it in sort of an abstract Java form. So within it, the very first thing we need to perform is a query, as you can see here. But pass into that query the name of the table, the name of the fields that we want to be returned to us. So in other words, this is sort of the equivalent of the very next thing. So whereas before we've been doing select star, what we are specifying here is the user field that we want to get. So really all we want is to get the user field from that table called users. And then the next one is the condition. So we have here, we want the condition, and this is really just a string. We want the condition so that the user is equal to, for example, J Harvard, and then the password is equal to J Harvard. But notice that rather than just inserting the data that's been passed into this authenticate user method, the user and the password, we separate out the conditions from the values themselves. So in this case, we have here key user equals question mark and key pass equals question mark. So in other words, what this actually looks like is this. And pass equals that, because that's exactly what we've written here. And then the next parameter right here is injected so the number of parameters, or rather the number of fields that you have within this next parameter must match the number of question marks that you have in your condition statement. So we can see here we have two fields, the user and the pass, which have been passed into us through the parameter list here in the method. So really then those are replaced. Oh no, we don't have backspace, or we don't have a left. These question marks are replaced with the data that has been entered by the user. All right, so then there's some additional things as well, like group by, having order by. If you need to use that additional complexity within your statement, you can implement that here. Otherwise, we can just say null to say that that's not applicable in this case. And this will then, oh, what did I do here? Selects user from users. Oh, I forgot the where clause up here. So just imagine that I said where up there, and that's exactly the query that's being created by this DB query method. So then that returns this data type that is called a cursor that allows us, we could, if we wanted to, iterate over all of the data that's been returned by it. But in this case, the logic that I mentioned before is that, first of all, we just need to make sure that we have received exactly one row back from that query. So all we need to do then is just to count the number of rows that have been returned by this specific query. If it happens to equal 1, then that user has successfully authenticated for the reasons that we mentioned before. For any other reason, if that query fails, let's say it returns null, or let's say that it returns 0 rows, or perhaps 2 rows, or something like that, then that user, there's something wrong. We should actually fail the authentication of that user. So really then, this authenticate user boils down to something very simple. It returns either true or false, depending on the conditions that we've set within. So it's not that bad, really, to use SQLite, as long as you understand that it is essentially this application that's being run and that you can communicate through your application here just by using this, by creating a database helper and by also instantiating a copy of the SQLite open helper, creating your own adapter. Can you abstract away the need to actually send these raw SQL statements to the database and be able to safely use it in your application? Any questions on this? Now, one of the things, yes?
Is that thing that's right in the that query that compared the two, that was the same thing as select star from users, where user equals something, password equals something that's
Wait, I'm sorry, can you repeat your question?
Authenticate user.
Yep.
Is that doing the same thing as select star from users?
It was doing this. So it's doing select user from users where user equals jharvard and pass equals jharvard. Now what? Oh my goodness, I cannot type in. All right, I have to do this again. Paste that, and then the last bit. I have to do this in an annoying way because it doesn't let me actually use backspace or anything like that. So this is really the data that's being returned. Really all it's returning is just the name of the user from that row that happens to match this particular query. So where before what we saw was select star, and the list immediately after select specifies which columns you want to be returned in the rows that happen to be matched by this query. So normally select star will return all of the columns for any rows that match your query. That's why for this query right here, select star from users where user equals jharvard and pass is equal to jharvard, this query right here, we are getting back all of the columns associated with the one row that matches those conditions. That's why we see three results, or that's why we see three columns right here, because that's the extent of the columns that we've defined within our table. But really, we don't need all of that data. As we've said before, the logic to authenticate a user in this case shows that really what matters more than the fields that are being returned is the number of rows. So we just want a very simple set of data that's being returned. In this case, we just want to select user from the, we just want to select that one user field from the table called users that happens to match, and for any rows that happen to match these conditions, where the username is jharvard and the password is jharvard. In this case, we then see that we only have this one example here, jharvard, but if it happens to be the case that I insert another row into it, insert into users. In fact, let's do this in the emulator, because now you can see how that this actually works. Notice that it says jharvard inserted. We don't have any protections right now within this code to make sure that we don't have duplicates. So if I actually take a look at all of the data that's been inserted into this table, we see that we have 3 rows, but 2 of them are identical except for the ID, right? So now if I actually query again using this select statement, select user from users where user equals jharvard and pass equals jharvard, what do we expect to see returned? So we're going to get 2 rows, but we only want the user field. So what we're going to see is jharvard, jharvard. When I hit enter, that's exactly what we see. That's because we've matched those 2 rows with these conditions where the username is equal to jharvard and the password is equal to jharvard, but we're only fetching the user field from that result set. So that's really what we're specifying. Just to simplify the amount of data that's being returned into the cursor, we really don't need any additional data other than that. In fact, we could just, it doesn't even need to be the key user. It could just be the ID field, for example, or it could be the password field, though probably we don't want to return just the raw plain text password in this case. But really, for this logic at least, what mattered more than the column was, in fact, the number of rows that was being returned. So you can update this query to suit your needs. So if you need more than just the user field being returned, then you could pass in. Notice that this is just an array of strings. We could pass in additional fields as well. So we could, for example, modify this so it's also the pass field as well. And we could then get both back in the cursor, but it's not necessary because we're not actually looking at that data in this code. Any questions on any of that? Yeah, you can also, there's also a way to specify that you want to get all of the data as well, and to have that select star field, or to have that select star query as well. All right, and that's databases in a nutshell. Let's take a quick 5-minute break. When we come back, we'll continue talking a little bit about storage and move on to threads. Hello, everyone. Welcome back. So before the break, we were talking about a variety of ways that you can actually store data within the context of your application. And we said how you can use basically 3 major ways in Android. Really, you can use the shared preferences, which is meant to be very lightweight and to store the state of an activity. You can use files if you want to read and write directly to the raw bytes of files on the file system. You can also use databases, as you saw in the example of Storage 03. Now, for those of you that are about to implement something that might actually benefit from using SQLite 3 in your student's choice application, then certainly Storage 03 will be a way to get started with that. But of course, the API documentation will be one of the best ways of finding out additional information about that as well. Speaking of the Student's Choice project, I do want to mention that the specification for that is up. You still have 2 weeks. Don't worry, I know you still have NPuzzle to finish up, which is of course due on Wednesday. But realize that this class is a bit quick, and in order for us to have time for you to get started with iOS in 2 weeks' time, then we have to get this student's project, or the Android Student's Choice project, out of the way. And what you will notice is that really the limitations that have been imposed within the Student's Choice project have been entirely made up by you in your proposal for your own project. We do specify a few requirements, like, for example, the minimum SDK version that you should use. You can update to a newer version of the API if you need to, but only if your project requires some API method that's available only in a newer version. But that is something that you can do, is to upgrade from API level of 7 if you decide that that's necessary. We also define some other things as well, like how you should name, or the package name that you could provide to your application. But in this case, you can actually name the app whatever you want. It's your choice to name it however you want, as defined for the context of your application. There's also something else that I want to point out as well. So not only will you submit to us the code, the source code for that Student's Choice application, but also you will pre-compile that. You'll actually create an APK file out of that source code and submit that as well. And also just a short, hopefully not too long, README file that tells us what the requirements of your application are, so that we know if it's something that has to be run on an emulator versus an actual physical device, if there's any prerequisites that your application requires for us to be able to use it effectively, anything like that. Basically just a how-to, how we can get started with that application, what it's supposed to do, just so that we have an understanding of how your application is supposed to run, how it's supposed to function, and that sort of thing. So keep those three things in mind. You'll submit not only the source code, but also the compiled APK file, and also a README document that tells us how and why and your application works the way it does. So with that, again, the specifications aren't really all that rigid. Hopefully you should soon hear back from your TFs, if you haven't already, on the proposals that you submitted already for your Student's Choice projects. Hopefully you've gotten some feedback about those, or you will very soon, about those projects, so that you now have a better idea where you can get started and what sort of things you might be able to accomplish. We do accept reasonable changes to these proposals, just because we know that when you first submitted these proposals, it was at the very beginning of us talking about Android, so it wasn't really clear what you might be able to accomplish. But now, hopefully, being as experienced as you are, especially having delved into NPuzzle quite as much as you have, hopefully you'll realize that there's perhaps a lot more that you can do than you perhaps initially thought possible, or there's some other things that are going to be a little bit more difficult. Hopefully you'll have a better idea of what it is that you'll be able to do for your application. Now, in the context of Android programming, there is one more thing that's very useful for us to talk about, and that is this concept of threads. There's something very important that we've not actually had a chance to take a look at yet in all of the previous source codes and all of the previous examples that we've seen up until this point. By default, an application on Android is single-threaded, and it's a single process. What this means is that everything that your program is doing, all of the computation that it's doing, and all of the responsiveness to the UI elements that it's performing are all done on a single thread. What this means is that if you actually are using a lot of computational power, or if you happen to be waiting for something, let's say you are initiating a very large database query, or you are about to download something from the internet, if you do this on the same thread, you can very easily lock up the phone. You can very easily cause it to become unresponsive. And a lot of the stuff that we've had a look at up until this point really didn't matter, because everything that we've been doing has been relatively instantaneous. Everything that we've been doing happens so quickly that it really doesn't matter that it locks up that single thread for the few milliseconds that it actually took to cause that to happen. But this can actually become a problem very, very quickly, as we will see in just a moment. So in Threads 01, this is precisely the sort of application that you should not, in fact, implement, because it is, in fact, very bad from the perspective of a user. This is Threads 01 right here. notice that there is an image right here. And if I tap on it, it actually animates. And what this is showing is that within this single thread, this one thread that not only is responsible for running all of my code in the activity, but also for updating all of the UI elements, responding to button clicks, responding to me actually interfacing with that activity, all of this stuff is happening in a single thread. And so right now, as this guy bangs on his computer because he's frustrated with NPuzzle, what he's trying to do, or what will happen if I cause this thread to do some computation for any length of time, will cause this animation to actually hang. So if I click on the sleep button, for example, which really doesn't perform any sort of computation whatsoever, but really what it's doing is causing the thread to sleep. So all it's doing is it's just sort of simulating what would happen if I had a for loop, an enormous for loop that was performing a lot of computation. You'll notice that for a brief few seconds, that animation actually paused. So let me do that again. I'll hit sleep. Notice that the animation is paused because the same thread that's updating that animation, that's actually changing this drawable image in this one image view, can no longer be run until we've actually made that finish. So if you saw that toast that said it's waited 10 seconds. Now normally this isn't maybe all that bad, right? I mean, that's kind of annoying that this happens. But where it gets really bad is if I cause it to sleep and I try to interface with this activity. I try to push other buttons. Notice what's happening. Nothing. It's not responding. And in fact, after 5 seconds of a thread, of the activity thread not updating, Android OS will bring up this dreaded message called ANR. The activity is not responding message. Now, if you create an Android application and a user gets this, guess what they're going to do with your application? They're going to force quit and immediately delete it because it's really frustrating, really annoying. It's not something that they want to have to deal with. Now, how then is this implemented in code? This is really a very, very simple application. If we just take a look at what's happening within the context of this application, we see that when I click on the button labeled sleep right here, this is in my on-click method that I've implemented within my activity. All that I'm doing is just telling this thread to sleep for a certain number of seconds, S seconds, and that's been defined above as 10. All right, so then after 10 seconds, I can actually then try to show that toast message, and we can see what happens as a result. Now, there's something that some people try to imagine as a fix for this, and that is using this concept of a runnable. So in this case, we could try to get around it with some code that actually looks like this. And now this code, what it does is it creates another method. It creates a method that will be run after a certain amount of time. And this actually, the very first time you look at it, and if you don't really know what's going on, it might sort of look in some sense that it's actually creating a background thread. But it's not. And it's very clear to me, it's very important to make that clear that when we're using a runnable and we're posting this to some later amount of time, we are not in fact initiating a background thread. So what then does it look like if I implement this? So I'm going to wait for this. Now notice if I click runnable, notice it says runnable posted. The animation continues to persist, right? And after that same amount of time, after about 10 seconds, should we actually see that same message appears that we've waited approximately 10 seconds. So this is where that confusion can sort of come up. And that, well, okay, so this is actually fixing our problem, right? This is actually waiting 10 seconds and then running this show message. It's not actually blocking the activity thread whatsoever. Well, there's a very important difference between what's happening when I click sleep and it's actually causing the entire thread to sleep versus posting a runnable. What a runnable does is it just delays some action from occurring for a certain amount of time. The thread is still active, but it's still all within the context of this same thread. There's still this one thread that's happening, that's causing all of this stuff to happen. And really what's happening when I post this runnable, and in this case I've created a runnable and I'm going to instantiate a version of that handler, and then I'm going to post it to wait for that number of seconds. When that's actually done, then I will then show that message that's been implemented within the run method that I've defined here. Notice that all it's doing is that it's just injecting this method, this run method that I want it to implement, or that I want that I actually want to occur within this event queue. And so this event queue is this sort of loop that's happening in sort of in a larger scope that's implemented outside of our activity. And it's basically just looping all the time, making sure that seeing if there's any touch events that are occurring, seeing if there's anything that has to run because of runnables being posted to it or what have you. And after a specified amount of time, it will try to run this as close to 10 seconds away as possible. So for those of you that are still working on NPuzzle, you might be thinking, well, you know what? Maybe this is a way that I can actually implement a countdown timer. In fact, this is one way that you can, in fact, implement a countdown timer to wait for a certain number of seconds. And then after those seconds are up, you can actually cause some event to occur, as you can see here. But it's important to realize that this is not a background thread. It's just posting it to the same thread, and it's waiting for that event handler or for that event queue to get to that at the specified amount of time. And so it's not going to be exactly 10 seconds necessarily. It could be impacted by other events that are happening within our activity or within our UI thread, but it's going to be close enough for the purposes that we want to implement here. So this is sort of a bad thing. And the reason that we know that this is not actually a background thread has to do with this other option that was implemented in this app. And that's this thing right here, sleep in the runnable. So if I actually tell this then that I want to run this runnable, and it's going to wait 10 seconds before that handler's actually run, before that run method's actually run, but then once it fires, there is an additional sleep method call that's happening in there. Notice what happens. It still is causing the UI to lock up. So this is not a background thread. If there was some large computation that was happening instead of sleep, and we posted it within our runnable, it's still going to cause our UI thread to lock up. And that will cause then users to be frustrated, because if they're trying to interact with it and nothing happens, then after about 5 seconds they get the ANR, they're just going to quit your application and uninstall it right away. So is there a way then that we can easily create background threads, that we can perform some long computation within that background thread before actually getting that data back, or before actually causing some update to our UI thread? Well, there's a couple of ways that we could do this. If you're knowledgeable in Java and you are familiar with threads, you could, in fact, implement your own threading mechanism. You could actually create your own thread, but there's a couple of very important things that you have to remember. First of all UI updates must update on the UI thread. You should not update any UI elements from a background thread. That's a big no-no. You'll get undefined results. It could be some really strange occurrences that happen in your application that are very difficult to track down as a result. And that's really not something that you want to do. And in addition, you should not perform any heavy computations on the UI thread for the same reason that we saw just a second ago, which was that we will cause the UI thread to lock, and we could then cause that ANR to occur. So you could, in fact, implement this on your own, but really there's a better way to do it. There's been a helper that the friendly people at Google have implemented for us to be able to make background threading relatively easy. And it will, in fact, deal with a lot of these complexities with locking and all of this other stuff that we really don't want to have to deal with as a programmer. So here then is the fix. So if I tap the image, notice that it is actually calling, that it's actually running this animation. And if I click asynchronous, it's going to start a background thread. And in the background thread, is it actually going to sleep a certain number of seconds? And then after a while, it's going to show a toast. Now, recall that a toast is something that has to be run on the UI thread. It's because it's some display that's actually occurring. So there has to be some way that we find out that this thread has actually completed its task, which in this case is just a very simple sleep task, and can actually return that data, or can actually return, and then we can run some additional methods to update our UI. So the way that this is handled is with an object called an async task. And an async task is just something that you can extend to be able to perform something in the background. So an async task just looks like this. All we are doing is extending an async task, and we're calling it, in this case, do some task, and we implement a few methods within this task. One of them is do in background, and one of them is on post execute. Now, the reason that these are important is because each of these methods are actually run in different threads. And in fact, there's a variety of other methods that we haven't implemented here as well that we could implement within our asynchronous task to get stuff ready. But this is just sort of a very bare bones, very basic implementation of running something in the background. Now, implementing this do in background method is the one method that is going to be run in the background thread. This asynchronous task is actually going to handle for us the responsibility of creating a new thread, running this method within it, and once that's done, or as progress actually occurs, it can then run other methods on the UI thread on our behalf without having to block the UI thread or without having to cause any of these sorts of concurrency issues or anything like that when we're trying to update elements on the UI thread from the background task. So do in background is a method that you will implement in your asynchronous task where all of the stuff happens in the background thread. So this method then that just has system clock.sleep, it's just opening up a thread and it's just going to wait about 10 seconds and then that thread will finish doing whatever it's doing, which in this case is just sleeping, and then it will return. Then once that's done, it will then call the asynchronous task will then call this method onPostExecute, which is run on the UI thread and allows us to update UI elements. This is very important because this means that we can update UI elements without having to worry about all of these threading issues or implement any of this stuff on its own. Now, there's a couple of other things that we can implement as well. OnPreExecute is a method that we could implement before the background thread is actually started. So if we had stuff to set up to get ready for the background thread, maybe there's some pre-computation that we need to do, or we need to pass some data to this class or what have you, that might be a good way of doing it. Another thing that we might use on pre-execute is to actually create, because that's another method that's actually run within the UI thread. We could actually create a progress bar, for example. Then another method that we might implement is one that's called onProgressUpdate. So whenever the background thread calls the specific method, and we'll see an example of this in a moment, whenever we actually call within the background thread that we have finished some finite set of data, or we've finished some finite set of computation that we're performing in the background, then we can update the UI thread, perhaps, because we have downloaded an additional image, or because we've finished another portion of computation that we're actually computing, or we've downloaded something off the internet, or whatever, what have you, that's been happening in the background. We can then update the UI because that is yet another method that's been implemented on the UI side, or that will be called through the UI thread, and then can prevent any sorts of concurrency issues or anything like that. So really then, this method abstracts us having to create all of that sort of complexity and having to deal with threading issues and concurrency issues and what have you. There's a few other things that I want to point out about the asynchronous task as well, and that is this right here. In our definition of the asynchronous task, notice that we have in these angle brackets 3 data types. Now in this case, they're all void. But as we'll see in a moment, we can actually specify other data types as well. But each of these are important because it allows us, and this is basically, if you're not familiar with this concept, you can look it up online. It's called Java generics. And generics just allow us to specify the data type that we want to use within some other methods. So notice that in this case, the very first generic that's defined, in fact, relates to the data type that's being specified in the do in background parameters. So if we were actually passing some data to our do in background method, let's say a list of URLs that we wanted to be able to download, for example, then we could specify that as being that particular type of data and then pass in that set of data. And this is important because Java is strictly typed, and if we didn't do this, then it would not allow us to have arbitrary sets of data that we could pass in to these methods. Now, so the very first one then, again, is the parameter that's being passed to do in background. Now, the second one, this one here that again is not implemented, is the type of data that we can pass from our background thread to our onProgressUpdate method. And that's not implemented here, so there's really not a good example that I can show you. But that's if you wanted to be able to pass some set of data that's been computed or downloaded or whatever from your background thread to your foreground thread to your UI thread, you could specify what that data is in that second generic. And this third one is the results. So what is actually being returned by our do in background thread. So once it's all done, what is the type of data that we're going to return? In this case, everything is void because there's not a lot of data that we're passing around. In fact, there's no data that we're passing around. Our background thread consists entirely of sleeping and just waiting for something to actually occur. Now, there are a couple of other things I want to point out about this as well. If you're curious about how we can actually get these animations to work in your own application, realize that this is really just a list, really this is just 3 images that are being run in sequential order with a specific delay applied to each one. And it really is very easy to implement animations within Android. In fact, in our resource directory in Drawable, you can actually find that we have a couple of files. There's 3 GIF files, Smiley 1, 2, and 3, and also an XML file. And this XML file, if we open it, specifies the animation or how those images should actually change within the context of an image view. So in this case, we can see that we have an animation list. So this really just specifies frame animation, or in other words, you have to already have created those frames that are then going to be used within this animation. But notice that we have here 3 of those items. The first one is this first smiley it's going to have a duration of about 250 milliseconds. And then smiley 2 and 3 are going to show for about 100 milliseconds each. And so the reason that this is happening is that you can sort of see that as he's pounding on his keyboard, there's a slight delay. He holds his hands up for a little bit longer than he's actually pounding the keyboard. That's where that delay is actually coming from. This just happened to be sort of the, I think, the best frame or the best duration for each of these frames for this particular type of animation. Now, when we actually want to implement this within our code, it's really not all that much more difficult than actually using some other resource. So here, you might have noticed that when I first opened up this application, it showed just one of the images, and that's fine. I just have defined that first smiley image as being the first one that I wanted to display. But when I actually want to use this animation, can I actually specify the XML file, that XML animation file that specifies the animation itself? This is just a resource file that's contained within our Drawable directory, and that XML file then, as you saw before, defines not only the other images that are used in this animation, but also the duration of each. So this XML file then really defines the animation that this image view is going to display on our behalf. So we then set the resource to that XML file that we've created in our Drawable directory. But then in order for us to start the animation, we just need these 2 simple lines of code. We just need to fetch the Drawable object that's been then loaded into the image view, into memory and instantiated within the context of this image view. And we need to typecast it as an animation drawable. Then all we need to do is to tell that animation to start with the start method. So this is a pretty easy way of implementing frame animation within your application if you want to do it. All right, so now to come back to this idea of the asynchronous task, notice that we have implemented this private class, doSomeTask, that extends this asynchronous task, and we specify those data types as I mentioned before. In this case, it's all void. In order for us to actually run this background thread then, all we need to do is to call that class doSomeTask and tell it to execute. So we just run this execute method. That again, this is one of those things where Android has implemented that execute method. We don't actually get to see it here, but on our behalf, is it actually creating a new thread? Is it actually running those other methods, the onPreExecute method, for example, and so on? And then it's actually in the background thread running this doInBackground method, and from there, will it perform all of those tasks in that second background thread. Any questions on any of this? Now, what if we actually want to do something a little bit more interesting than what we can actually see here? Well, if we take Intense08, which you might recall was that sort of simple gallery application that displayed a gallery of images, and then we could click on one and it would load just that one single image, and we sort of took it to the next level. Let's say that we actually want to enable that same gallery application to be able to download images from the internet. And we wanted to do it in such a way that it doesn't actually cause the UI to lock up. So it's actually going to download those images and display them as they are being downloaded, or as the download actually completes and as the thumbnail is actually created for each one of those. It looks like this right here. Notice that what's happening is that as this is downloading from the internet, is it updating the activity? Is it updating the grid view? And we can actually see then the images that are being downloaded as a result. And so here, there's a little bit of a white lie. Our servers are kind of fast, and so I'm introducing an artificial delay, but it's not that long. But still, you can sort of see how this works now by slowing it down, as we've done. You'll see in code in just a minute. But all of these images were downloaded, and they're in fact not included within the drawable directory of this application, but they are in fact being downloaded from the internet, cached, or rather the thumbnail generated and the thumbnail cached in memory, and then we can actually see, then we can actually show those images that we've downloaded and displayed in this application. So how then are we able to get this to work? Well, code 3 is the activity that we're going to perform all of this in, but really all of the magic, all of this stuff happens within an image adapter that we've created. So this URL image adapter is going to be the one that's responsible for downloading all of the images. Perhaps it knows somehow the images that we need to download. Perhaps it knows somehow the list of images that we need to download, and it's actually going to, on our behalf, download those images and create the thumbnails. And just as you've seen in Intense08, we can then pass that data to the grid view and update the grid view whenever we have some new thumbnail that's been generated, that's been created by this application, or rather by this image adapter. So pretty much everything else is as you would expect here, except there is one thing that we're going to talk about in just a moment, the on-retained configuration instance, but we'll come back to that in just a little while. Now, how we actually implement this URL image adapter is in the following way. It's very similar, perhaps in some ways, to the image adapter that we defined in Intense08, but rather than actually using reflection, Java reflection, to find out the files that are contained within our drawable directory, which, by the way, now looks very barren because we only have two things. A blank icon, which is used as a placeholder until that thumbnail is actually downloaded. The contrast, I'm not sure if you actually saw them. It's like just sort of a grayed out little camera icon that will be replaced by the actual image when it's actually been loaded. And then, of course, then our icon for the application itself. Those are the only things that are bundled with this application. Now, the URLs, though, in this case, have been specified here. Just in a list, in an array of URLs that we want to download, and this has been predefined just with the list of those files that we want to display within this activity. So there's other ways that we could fetch this list as well. Perhaps we could download a single file that contains a list of images, and then we could use that. But in this case, we just want to simplify some of these things so you can see how we can implement at least the basic version of this, and then from there can you iterate to additional complexity as well. So we have here then an array of images, presumably that we want to download from the internet. Now, if we take a look then at our constructor method for our URL image adapter, we can see a couple of things. First of all, that we have this load thumbs task, and it's really this task, which again is a class that we've extended from the asynchronous task class, that's going to be responsible for pulling those images and creating thumbnails for them. Now, how this works is that we've created an array of type images and made it as long as the list of URLs that we had. Now, notice that we have here that object type, or that object called an image, that contains two fields. A string representing the URL of that image, and also a thumbnail or a bitmap that is going to represent that cached thumbnail. And we're just going to have an array of those images. Perhaps at first, what we're going to have is an array that's the same length as the URL list that we saw just a second ago, that has at each index one of these objects. And at first, when we first start out, all of the URLs are going to be filled by that same URL that match. They're going to have corresponding URLs to that index, or to the corresponding index that we saw in the URL list below. But also will we have null thumbnails. We're not actually going to have any thumbnails to display for the user quite yet. And in fact, whenever we are trying to get a view, we can take advantage of that. This getView method, which we've seen again from Intense08, is very similar to the one that we saw in Intense08. But in this case, what we're doing is if that cached thumbnail just so happens to be null, we're just going to set the view at that specific point, that one specific node at that grid location. We're just going to set it to be that blank image. to show the user that that image has not yet been downloaded, and we want to, that we're working on it, we're going to download it as soon as we can. Otherwise, we can in fact use that cached thumbnail as we saw before. So far, so good, right? So far, hopefully this makes sense. Obviously now, we haven't yet connected how we can fill in this cache data and how we can tell the adapter that we've updated this data and that we want to recreate, or we want to recreate that view that now has a cached data. But really, all of that magic happens, and really it's not all that much magic, all of that happens when we execute that thumbnail gen, or when we execute that task that is going to be responsible for downloading all of that stuff. So this then implements, and again, remember that just because this is a separate Java file, unless we actually create a separate thread, it's not actually going to run by default in the background. There's not actually going to be a separate thread that's created for this URL image adapter. We actually have to take the reins into our hands and create a separate thread on our own if we want this task to happen in the background. So we have then this asynchronous task that is going to do precisely what we mentioned before. So notice that we have here our load thumbs task, and it extends our asynchronous task. Now notice that what we're passing in to this asynchronous task, and specifically the parameters that are going to be passed to the doInBackground method, are in fact an array of type image. And we saw, of course, image above, which was that combination of URL and cached thumbnail. So now we presumably know which of those have already generated thumbnails, which ones need to generate thumbnails, and we can iterate over each of those to find out or to download those images and use them or create our thumbnail and then insert it into our image object and then be able to use that and display it on our grid view. So notice that what we have here, we're just defining some of the bitmap factory options as we talked about at length with regard to in sample size before. We can reuse that here, and we can iterate over each of the objects in our array that's been passed to our method here, as you can see. Now notice that this type image matches the generic type that I defined above in the first angle bracket, and also notice that there's this ellipsis, ... That just means that what we are essentially getting is an array of type images. Now, whether or not we define each of these images individually above, which we could do, we could pass in an individual image here and then another individual image, so on and so forth. We will just get an array of those images. But in this case, I've already defined this array of type image that's the same length as those URLs. And so I just have to pass in then that array of objects that I've created as shown above. But within this background thread, there's a few things that are happening. Now, there's something very important to realize here, and that is that asynchronous task can only be run once at a time. When you are running this background thread, you cannot tell this same task to execute multiple times. So what that means is that you cannot implement this in such a way to download a single image and then just mass create, I don't know, a dozen different threads to download each of those images individually. It's not going to work that way. It's not going to allow you to run that many threads. It will actually tell you, well, okay, there's no way the asynchronous task can be used for more than one thread at a time. So consider this as though you have one background thread that you can create, and so you have to perform all of your computations in that one thread. So what that means is that if I have a list of images that I need to download, I can't assign a different background thread to each of those images. What I have to do is I can create a single background thread, and I have to download each of those images in that one background thread. That's precisely what we're implementing here in the doInBackground method. We're passing in that array of objects with the URL filled and the bitmap thumbnail null, and we know then which ones we actually need to download and to create. So essentially then what we're doing is in this background thread that's happening while everything else is happening in the foreground. We might be displaying some views, we might be scrolling the image adapt, or rather the grid view. We could be doing a variety of things. In the background, what we're going to do is iterate over each of those image objects and download them. We're going to call this method called loadThumb. Now, loadThumb is a method that I've implemented above, but don't be confused. Just because it's implemented outside of the context of asynchronous task, this method is being called by the background thread. So all of this stuff is happening in the background, even though this method has been implemented outside of the asynchronous task. And that's just purely because of where that method call is occurring. Now again, recall that, scratch that. So here, within the load thumb, notice what's happening. I am accepting a URL, and I am expecting to return the thumbnail that's resulting from that. And so from that, can we actually then create a few things? So notice that here, what we need to do is to open up a connection to that URL, download the stream of data from it, actually interpret that as a JPEG file. And in fact, notice that we are using our decode stream, our bitmap factory, so we can define, again, our in-sample size so that we can, as we're decoding it, we're not going to run out of memory. It can be an enormous file, but we can still subsample it and get it very close to our thumbnail size that we want. Then we're going to close that stream that's been opened up for downloading that image file. Now, when you actually perform one of these connections and you actually download some stuff from the internet, notice that there's a couple of exceptions that can occur here. Malformed URL exception and this other one as well, IO exception, if something actually happens to occur during that connection, perhaps data connection is lost or what have you, then we can actually log those errors or do something appropriate. But again, you cannot actually update the UI from this context. You cannot, because this is running in the background, and we said before that the one thing that you cannot do from another thread is update UI elements. You cannot actually do that. There's another way that we can do this. In this case, we're just implementing, we're just asking the log to save the fact that there was an error, but I'll describe a way that you can actually notify the UI that some error has occurred in just a moment. Now, assuming that all of this has occurred successfully, though, we've downloaded all of this information, we've decoded the stream, we can then return the thumbnail that we've generated. And so it goes back, of course, to this original method, the do in background method, and we can save within our individual image object the thumbnail associated with, or the thumbnail that we've just downloaded and created and sampled so that it's now a smaller version, there. So once that's done, we've completed one unit. We've downloaded one of those thumbnails, and we now have it cached and saved within our array. But now we need to be able to tell the grid view that this has actually finished in the background. So this asynchronous task actually implements this method called publish progress. And what publish progress does is that it goes back into this UI thread, and it will actually call this onProgressUpdate method. And from that onProgressUpdate method, because this is now being run on the UI thread, can we actually then perform some change on the activity itself, or within the UI elements that exist within the UI thread. In this case, I'm going to call another method that I've implemented outside of the context of this asynchronous task called cacheUpdated. Now, this one is, in fact, going to be the method that is called in the UI thread. Because again, the onProgressUpdate method is going to be run on the UI thread, so this one is as well. This method call will occur in that thread as well. And all I'm going to do is to tell the adapter that its data set has changed, which means that it needs to notify the grid view, and the grid view is going to then fetch the new data out of that adapter. So just by telling the adapter that the data set has changed, will it then update, and will it go back through all of these views and actually find out, do we have an image at a specific position? Yes, we do. In this case, does that have a cached thumbnail? Well, that's one. We now suddenly have one that we've downloaded, so we can actually set that image view to be the one that we had just, or the cached view that we had just processed, downloaded, and saved within our array. Now, if you happen to have an error or something that might occur within the context of your background thread, and you need to notify your foreground thread, you might use onProgressUpdate, for example. You might actually return from your do in background method. There's a number of things that you can do, but basically what you need to do is to somehow call a method that's going to be run on the UI thread before you can actually notify the user within the context of those UI elements. Again, it's just very important that you do not try to update any UI elements within your background thread, or you could get undefined results there. All right, so notice there's a couple of other things that are happening within this loop as well. First of all, we're just checking to see if a thumbnail has already been generated. If it has, then we're just going to skip. We're not going to re-download that thumbnail. In fact, this becomes a lot more useful in just a moment, as we'll see. But also, do we ask this question of our asynchronous task? Has it been canceled? we run this method isCanceled, which has been implemented by the async task class, and it will actually notify our background thread whether or not the asynchronous task has been canceled. Now, the reason that it might be canceled was because perhaps me and the UI thread has decided that it's no longer useful to run this background task, and so I can tell the asynchronous task to stop its processing. Therefore, as a result, it will no longer it will tell the background thread that it can be canceled in this format. But in any case, if you have some long computation that's occurring, or if you have a whole bunch of stuff that's actually happening in your background thread, you really need to periodically check if that background thread has been canceled. So then that way you can then clean up whatever data you need to clean up, and then you can return and just stop that background thread from continuing its process. All right, so hopefully then this isn't really it's really not all that difficult to implement something like this in the background. We can, in fact, implement all of this stuff and perform this this download of information in the background. Now notice that here I'm just adding an additional half second of latency. Otherwise, it sort of loads a bit quickly. This isn't. This really is shown purely for your benefit, so that when you look at this application, you can actually see as each of the images are downloaded. We really don't need this in our background thread other than that. But there's another thing that I want to point out with this this set of data as well. So if I rerun this application. And I know it's not on screen quite yet, so I just want to, oops. I know it's not on screen quite yet, so what I'm going to do is uninstall this application. You'll see why I'm going to do this in just a moment. We have, or rather, I suppose what I should do is stop this application from running, because right now all of this data is being saved in the background. I want to force stop it. Yep, all right, now let's reopen that application. Now hopefully now it will restart what we saw. So yep, here it is downloading the images. Now notice what happens when I actually change the orientation of this phone. What it does is it continues downloading from the last position of images that it had downloaded before. So it's not actually restarting any of this task. Now, typically what would happen with a background task, if we were to destroy all of this stuff, if we were to destroy, because as you know, or as you might know, when you change the orientation of the device, it actually goes through the activity lifecycle. It destroys the current activity and then recreates it. So there's perhaps some way that we need to be able to tell the activity that we've already started working with some of this data. We don't want it to destroy it, but we want to pass that data from the current instance of that activity to the subsequent instance that we know is about to be run. Well, we can do that by implementing within our activity this method here, onRetain non-configuration instance. So what this means is that when this method is called, this activity is about to be recreated, and we want to pass some data from this instance of the activity to the subsequent one. I'm going to give you a little bit of a hint here. You don't actually have to implement this for NPuzzle. You should not need, so I mentioned before when I demoed NPuzzle that when you perform an orientation change, if you are implementing it correctly, you sort of should get for free the fact that the orientation change happens. And I've seen a lot of chatter online about using this onRetain non-configuration instance. You don't have to do that. In fact, the staff solution completely avoids having to use this method in the implementation of NPuzzle. So just so that you know, I'm showing you purely for your own information and not necessarily to show you, oh, you have to implement this in NPuzzle. In fact, the specification doesn't even explicitly define what you should do in an orientation change, and the things that are not explicitly defined in the specification you are free to interpret as you will. So if it just so happens that your application doesn't properly handle an orientation change, then that's okay. You won't get docked for that. However, it is usually indicative of a larger problem if your application doesn't actually properly handle that in the first place. And that's why I just recommended and mentioned before that you check to make sure that it handles orientation changes properly, because if it doesn't, then most likely there's some other thing going on with your application unrelated to the non-retain non-configuration instance that's causing your application to fail. Perhaps your algorithm for determining the resize of that image is incorrect. Perhaps you're not actually performing the save state or recreating the state in the activity lifecycle properly. There's a variety of things that could be going on that are indicative of a larger problem. So just keep that in mind, that we don't actually require that your application handle orientation changes, but usually it's indicative of a larger problem. That's all that that I want to say about that. So this then is purely for your own information and not necessarily something that you must implement for NPuzzle. But if you want to create an application that can survive data between multiple orientation changes, this is useful, especially since we're now starting to use background tasks. What this means is that we're going to be generating some data, and we don't want to have the user start all over again once that data or once that activity has been destroyed and then recreated because of an orientation change. So with that said, we can implement this method on retained non-configuration instance, and what we want to return, and this again is a method that's being called by the activity when it's being destroyed and it knows that it's about to be recreated, we want to return the data that we've already created within our adapter. Now, is this the best way to do this? Well, obviously there's a number of ways to do this, but basically what we are doing is we're asking our adapter, in this case, if there's any data that it has in fact processed, and we're going to return that object to this to the calling method, and the calling method will retain that object, and when the activity is actually recreated, we can then use that data. And in fact, now to bring this sort of in a big loop back to what we've seen before, this method here, getLast non-configuration instance, will actually return the data that's been saved, if any, and we can then use that data. We can then pass that data back to our adapter and say, hey, look, I know you were just doing your thing a little while ago. Here's some of the data that you've already calculated, some of the thumbnails that you've already calculated. So why don't you use this data instead of starting over from scratch? So this method then returns that data that I'd saved previously in that previous method on retained non-configuration instance. And this data, even though, and notice that it's a generic type object in this case, and I'm just passing that data back into my URL image adapter, and the URL image adapter will be responsible for fetching that data, making sure that we can, and reusing the data that has already been passed to it. So in this case, in the constructor, as we saw before, and I really glossed over, notice that there was this, this parameter in the constructor, object previous list. And previous list is in fact the data that has been saved, that has been retained on this configuration change from one orientation to the next. And so what I'm doing here is I'm finding out, is this previous list null? If it is, then that means that this is a fresh start. There's no previous data that's being created. And so then really what I need to do is go through the steps that we saw before just a moment ago where this is not null. So down here, this is the steps that I mentioned before, where we need to create an instance of that array. We need to create an appropriate size for it and fill it with URLs, so on and so forth, set all of the bitmaps equal to null, and then actually start the background task as we saw before. But if that data actually happens to exist already, then I need to tell my current object or my images array that this is the data that I want to use. So notice that I'm typecasting it from its generic type of object to an array of images as we saw before, because I know that that's the type of data that I've actually been returned, that I returned in that getData method that I implemented below. But from that, I can see that I've already generated some data, and so what I'm going to do is then tell my background thread to execute with that data that has been saved between, or that has been preserved between configuration changes. And this is why I had that one if statement in my background thread. If the thumbnail is not equal to null, then continue, because this asynchronous task, this background thread, is going to start over from the beginning, but if I've already generated that thumbnail, then I don't need to worry about generating it again. So I'm just going to skip over this current thumbnail that I've already created and find the ones that I have not yet actually created. All right? So recall that in the activity method, what I had was this onRetained non-configuration instance, and I fetched the data from the adapter. This getData method really is very simple. All I need to do within it is to be able to return the data that I've so far generated. In this case, it's that list of images. But there's also one more thing I need to do, and that is to tell the asynchronous task that it no longer needs to do its thing. We should, in fact, cancel this background thread because no longer are we going to be using it. It's going to be recreated, and a new thread is going to be spawned when the whole activity is then recreated. So what I need to do is notify my asynchronous task that it should cancel. But I should only do that in the case that it has not already been finished. So if it's still actually running, then what I need to do is to cancel that task. And this, again, is why we had that other if statement in the background thread below, which was if it is canceled, then we're not going to continue processing any additional thumbnails. So all of this stuff then comes full circle based on our asynchronous task. And so with that then, have you been given this opportunity to see all of the ways that we can use, well, all right, so there's a lot more ways that we can use threads, but can you actually create a thread in a very easy manner just by extending this asynchronous task? And in fact, I highly recommend, if you need to use background threads in your application, that rather than try to implement threads on your own, because there's a lot of concurrency issues and a whole lot of issues with running methods from in the UI thread versus the background thread, use this asynchronous task. And for the vast majority of things that you need to do in the background, will this actually do what you need it to do? Now, unfortunately, what this doesn't do for you is things like if you want to play music, for example. This is not the appropriate way to do that. You would instead use a service, which is sort of like everything that we've seen up until this point. We've implemented activities, which are those objects that interface with the user directly. But there are other objects as well that we could create, like broadcast receivers, which are actually called when something occurs at the OS level, and we actually need to notify our application that some state has changed or something has happened within the context of the OS, or even some other things as well. There could be some broadcasted events that our application actually wants to know about, or even something like services, which would be more appropriate for things like playing music in the background. Really what asynchronous task provides to us is the ability to perform computations for that activity in the background, or to perform some task that's going to take a non-trivial amount of time, something that is basically not going to be instantaneous. We can perform in this background thread and update our activity whenever we have an update to that data. So with that, thank you all very much for the past 5 weeks of Android, and I can't wait to see the results of each of your student projects. Next week, of course, is spring break, so you have all of that time. You have an extra 2 hours to work on your student choice projects. And in 2 weeks from now, we will actually start with Objective-C and iOS. David Malin will take over the course at that point, and he will then get to get basically the iOS version of all of this same stuff. So with that, thank you all very much for coming. Hope to see you in a few weeks.